Hello friends, we will solve some problems on linear differential equation with constant coefficients. First we solve d raised to 4 minus 3d cube minus 6d square plus 28d minus 24y equal to 0. To solve this differential equation, we shall find out first auxiliary equation of this. Auxiliary equation is m raised to 4 minus 3m cube minus 6m square plus 28m minus 24 equal to 0. Now to find out the roots of this equation, we shall use trial and error method. As sum of all coefficient is not 0, m equal to 1 is not root of this equation. Sum of even powers of m, coefficient of even powers of m, and sum of coefficient of odd powers of m are not same. Therefore m equal to minus 1 is also not root of this equation. Therefore we shall put m equal to 2. 2 raised to 4 is 16. 2 cube 8. 8 into 3 minus 24. 2 square 4. 4 into minus 6 minus 24. 2 into 28. 56 minus 24. 24, 24, 24 minus 72, and 56 and 16 is 72. 72 minus 72 is 0. Therefore, m equal to 2 may be the first root of this equation. m equal to 2 is the first root of this equation. Therefore, we shall divide synthetically by the factor m minus 2. m equal to 2 is here. Now I shall write the coefficient in decreasing order. 1 minus 3 minus 6 28 minus 24. 1 is carried as it is. 1 into 2 is 2. 3 minus 10 and 2 is minus 1. Minus 1 into 2 is minus 2. Minus 8. Minus 8 into 2 is minus 16. That is 12. 12 into 2 is 24. 24 minus 24 is 0. Therefore, again 1 minus 1 minus 8. 2. Again we shall check whether 2 is a root or not. If 2 is a root, then this term will become 0. 1. 1 into 2, 2. 2 minus 1 is 1. 1 into 2 is a 2. Minus 6. Minus 6 into 2 is a minus 12. Therefore 0. Therefore m equal to 2 is the second root. Therefore m raised to 4 minus 3m cube minus 6m square plus 28m minus 24 can be written as m minus 2 into m minus 2, that is m minus 2 square m square plus m minus 6 equal to 0. Minus 6 has the factors 3 and 2, and 3 minus 2. Therefore this can be written as m minus 2 square into m minus 2 into m plus 3. Thus m minus 2 bracket cube into m plus 3 equal to 0. Thus we get m minus 2 bracket cube into m plus 3 equal to 0. That's why m equal to 2, 2, 2 and minus 3. Therefore, general solution of the differential equation is y equal to C1 plus C2x plus C3x square into e raised to 2x plus C4 e raised to minus 3x. Our problem is solve d cube plus 6d square plus 12d plus 8y equal to 0. Auxiliary equation is m cube plus 6m square plus 12m plus 8 equal to 0. Therefore, clearly this is m plus 2 bracket cube. Therefore, roots are minus 2, minus 2, minus 2. Therefore, general solution is y equal to C1 plus C2x plus C3x square e raised to minus 2x. Solve d cube plus 3d square plus 3d plus 1y equal to 0. Its auxiliary equation is m cube plus 3m square plus 3m plus 1 equal to 0. Clearly, this is m plus 1 bracket cube. Therefore, m equal to minus 1, minus 1, minus 1. There are 3 roots. Therefore, general solution is y equal to C1 plus C2x plus C3x square e raised to minus x. Solve the equation d raised to 5 minus d cube y equal to 0. Its auxiliary equation is m raised to 5 minus m cube equal to 0. M raised to 5 minus m cube equal to 0. From this we can take m cube common into m square minus 1 equal to 0. Therefore, m cube into m plus 1, m minus 1 equal to 0. Therefore, m equal to 0, 0, 0 repeated 3 times, minus 1 and plus 1. And hence, general solution is y equal to C1 plus C2x plus C3x square e raised to 0x is 1 plus C4 e raised to minus x plus C5 e raised to x. Our problem is solve d raised to 5 minus 16 d cube y equal to 0. Its auxiliary equation is m raised to 5 minus 16 m cube equal to 0. If I take m cube common, m square minus 16 equal to 0. 16 is 4 square. Therefore, this can be written as m cube into m minus 4 into m plus 4 equal to 0. Therefore, m equal to 0 is repeated 3 times, 4 and minus 4. And hence, general solution is y equal to c1 plus c2x plus c3x square into e raised to 0x. E raised to 0x is 1 plus c4 e raised to 4x plus c5 e raised to minus 4x. Solve 4d raised to 4 plus 4d cube minus 3d square minus 2d plus 1 y equal to 0. Now, to solve this differential equation, we have to write the auxiliary equation. Auxiliary equation is 4m raised to 4 plus 4m cube minus 3m square minus 2m plus 1 equal to 0. Now see, sum of all coefficients 4 plus 4 8 minus 3 5 5 minus 2 3 3 plus 1 4 is not equal to 0. Therefore m equal to 1 is not root. Now we shall take coefficients of even terms, that is m raised to 4 4 minus 3 plus 1, that is 2. Coefficient of odd terms 4 minus 2, that is equal to 2. Coefficient of even terms equal to coefficient of odd power terms. Therefore m equal to minus 1 is a first root. We shall use synthetic division for finding other roots. We shall divide by m plus 1, that is m equal to minus 1 here, and then coefficients in decreasing order 4 4 minus 3 minus 2 and 1. Now we shall carry 4 as it is. 4 into minus 1 is minus 4. Sum is 0. 0 into minus 1 is 0. Minus 3. Minus 3 into minus 1 is plus 3. That is 1. 1 into minus 1 is minus 1. Therefore it is 0. Again we shall try to divide by minus m equal to m plus 1. M equal to minus 1. 4. 4 into minus 1 is minus 4. Therefore minus 4. Minus 4 into minus 1 is 4. Minus 3 plus 4 is 1. 1 into minus 1 is minus 1. That is 0. Therefore 4m raised to 4 plus 4m cube minus 3m square minus 2m plus 1 equal to m plus 1 2 times. M equal to minus 1 is here. Therefore m plus 1 2 times m plus 1 square into 4m square plus minus 4m plus 1. This is nothing but m plus 1 bracket square into 2m minus 1 square. This is a perfect square, 2m minus 1 square. Therefore, if this is equal to 0, we have m equal to minus 1, minus 1, 1 by 2 and 1 by 2. These are the 4 roots. Minus 1, minus 1, 1 by 2, 1 by 2. Therefore, general solution is y equal to c1 plus c2x into e raised to minus x plus c3 plus c4x into e raised to minus 1 by 2x and e raised to minus x by 2. This is the general solution. solve d raised to 4 plus 3d cube minus 6d square minus 28d minus 24 y equal to 0. Here auxiliary equation is m raised to 4 plus 3m cube minus 6m square minus 28m minus 24 equal to 0. Now, here, if you collect the coefficient of all terms, 1 plus 3, 4, 4 minus 6 minus 2, and all are negative, therefore it is never 0. If you take coefficient of odd even powers, 1, minus 6 and minus 24, minus 29, and coefficient of even odd powers, 3, minus 28, minus 25, they are not equal. Therefore, m equal to minus 1 is not root of this equation, m equal to plus 1 is not root. If I put m equal to minus 2 raised to 4, that is 16, minus 2 cube 8, minus 8 into 3 minus 24, minus 2 square 4 into minus 6 minus 24, plus 56 minus 24. Therefore, this is 0. Therefore, m equal to minus 2 is root. Therefore, we shall use a synthetic division for finding others. 1, 3, minus 6, minus 28, minus 24. What we have done? We have written all the coefficients in decreasing order. Now, 1 as it is carried, 1 into minus 2 is minus 2, 3 minus 2 is 1, 1 into minus 2 again minus 2, minus 8, minus into minus 2 minus 16, plus 16, minus 8 into minus 2 is 16, 16 minus 28 is minus 12, minus 12 into minus 2 is 24, 24 and minus 24 is 0. Therefore, m equal to minus 2 is the first root. Again we shall try to divide by minus 2. 1 into minus 2 is minus 2, minus 2 and 1 is minus 1, minus 1 and minus 2 is a 2, and 2 and minus 8 is minus 6, minus 6 into minus 2 is a 12, 0, therefore minus 2 is the second root. Again we shall try it minus 2, 1 into minus 2 is minus 2, minus 2 and minus 1 is minus 3, minus 3 into minus 2 is plus 6, therefore it is 0. Therefore, m raised to 4 plus 3m cube minus 6m square minus 28m minus 24 equal to m plus 2, m plus 2, m plus 2, that is m plus 2 cube into m minus 3, and this is equal to 0. This implies m equal to minus 2, minus 2, minus 2 and 3. Therefore, general solution is y equal to c1 plus c2x plus c3x square e raised to minus 2x plus c4 e raised to 3x. Our problem is solve the differential equation d raised to 4 plus 3d cube plus 2d square y equal to 0. D raised to 4 plus 3d cube plus 2d square y equal to 0 with the conditions x equal to 0, y equal to 0, y dash equal to 4, y double dash equal to minus 6, y triple dash equal to 14. That means we have to find out particular solution of this problem. We shall find general solution. That is, for that we read auxiliary equation. Auxiliary equation is m raised to 4 plus 3m cube plus 2m square equal to 0, which can be written as m square is taken common, m square plus 3m plus 2 equal to 0. That is nothing but m square into m plus 1 into m plus 2 equal to 0. That is 2 can be written as 2 into 1. Therefore, m equal to 0, 0, minus 1, minus 2. Therefore, general solution is y equal to c1 plus c2x into e raised to 0x, that is 1, plus c3 into e raised to minus x plus c4 into e raised to minus 2x. Now, on this equation, we have to use these boundary conditions. That means we require y dash, we require y double dash, we require y double dash, triple dash. Therefore, we differentiate this y. Therefore, we will get y dash equal to derivative of c1 is 0, derivative of c2x is c2 plus c3 into e raised to minus x, that is minus c3 into e raised to minus x minus 2c4 into e raised to minus 2x. Again we differentiate second time y double dash, derivative of c2 is 0, c3 into e raised to minus x plus 4c4 into e raised to minus 2x. Again differentiating third time, y triple dash equal to minus c3 e raised to minus x minus 8c4 e raised to minus 2x. Thus we have differentiated. Now we shall use the condition when x equal to 0, y equal to 0. Therefore, y equal to 0 in 1, x equal to 0, therefore c1, c2x, therefore this becomes 0, plus c3 plus c4. This is equation second. Now when x equal to 0, y dash equal to 4, y dash equal to 4, x equal to 0, therefore c2 minus c3 minus 2c4. Third equation. When x equal to 0, y double dash equal to minus 6, minus 6 equal to c3 plus 4c4 and y triple dash equal to 14 when x equal to 0, minus c3 minus 8c4. We have to solve these four equations for finding c1, c2, c3, c4. Therefore, we shall solve fourth and fifth. We shall solve fourth and fifth. c3 plus 4c4 equal to minus 6 and minus c3 minus 8c4 equal to 14. If I add these two, c3 minus c3 get cancelled. 4c4 minus 4c4 equal to 14 minus 6 is 8. Therefore, c4 equal to minus 2. I got c4 equal to minus 2. If I put this value of c4 in any one equation, 4 or 5th, I can get c3. Therefore, c3 equal to minus 6 minus 4c4. That is equal to minus 6 minus 4 into minus 2. 4 into minus 4 into minus 2 is 8. 8 minus 6 is plus 2. Therefore, c3 equal to 2 C4 equal to minus 2. We shall put these values in 3. We can get 4 equal to C2 minus C3. Minus C3 is minus 2. Minus 2 times C4 minus 2. Therefore, C2 equal to 4 plus 2 minus 4, that is equal to C2 equal to 2. Thus C2 equal to 2, C3 equal to 2, C4 equal to minus 2. From equation second, C1 equal to minus C3 minus C4, that is equal to minus C3 means minus 2, minus C4 means plus 2, that is equal to 0. Thus we get C1 equal to 0, C2 equal to 2, C3 equal to 2 and C4 equal to minus 2. Substituting these values in 1, we get particular solution. Y equal to C1 is 0, C2 is 2, 2x plus C3 is 2, therefore 2 e raised to minus x, plus C4 is minus 2, so minus 2 e raised to minus 2x. This is the required answer. Thank you.